good day to all the viewers. This is the session regarding intermediate chemistry. On the international floor, if you are preparing for any entrance or competitive exam, the session will be very much helpful. India level, Indian government is conducting JEE Advanced, JEE Mains exam, that is for IIT, and NIT entrance examination. That will be the technical domain. NEET chemistry will be there. That is for what? Medical entrance examination across the India. Telangana and Andhra Pradesh government are conducting the exam called the MCET examination. That will be fetching for your BTech entrance exam. In addition, if you are preparing for government conducted government jobs, so that general studies common question paper will be found. In that general question paper, general studies question paper, general science content will be there. The session what we are discussing will be helpful for that kind of preparation as well. Let's enter into our today's session. Question number 1 related with the coordination complex IUPAC nomenclature. Explain the name of coordination complex as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Copper Cl4 whole to the power -2. This is the anion which is provided. We have to give the IUPAC nomenclature followed chemical name for this. The name of the compound is being it is the tetrachloro, right? 4 chlorines you can locate so that we can say tetrachloro. It is called a tetrachloro, and the anion will be there. Whenever any complex is mentioned with the negative charge, metal suffix will be 8. Just now we discussed in the earlier session. Any metal which that complex is having negative charge over there, so that we have to put suffix as a 8 in front of that metal, central metal, right? So that let me say tetrachlorocuprate, and let me count the oxidation state of the central metal. So here 4 chlorines contributing 4 negative charge, and 4 negative charge cancelled with the 2 negative charge, so that leftover will be 2. The 2 negative charge counterbalanced by +2 charge on the copper metal. So that here 2 Roman letter indicates +2 charge on the copper. So entire name will be tetrachlorocuprate 2 ion, right? So here we are not having a neutral complex, rather here -2 charge is there. That's the reason why ion can be mentioned. And we have 4 chloro, so the tetrachloro is mentioned over, and copper is existing in the form of negatively charged complex. That's the reason why cuprate will be assigned, and copper existing in +2 oxidation state on the central metal, so that 2 Roman letter is indicated. Just completion of that metal we have to write this, and it is the ion. Tetrachlorocuprate 2 ion is the IUPAC nomenclature. Here always we have to understand that cation name should be mentioned first, later on anion name will be. Okay, if you are taking sodium chloride, sodium is the cation, chlorine is the anion. Always cation name should be pronounced first, later on anion name will be given. So this is the way the name of the complex is provided as per the IUPAC protocol. Move on to question number 2. Question number 2 collected from Cambridge Assessment International Education. Iron is a transition element. The list of properties of iron are shown to you. Iron is the good conductor of electricity. So can you give the example for this one? Iron is the good conductor of electricity. This is the kind of justification we are going for. So here, everybody aware that all the metals are good conductors of electricity. The examples for the conductors are iron, saline water, and copper. Any electrical conductor which pass the current through them, so that able to pass current from one place to another, which are said to be conductors. And insulator will seize the current passage, which are called insulators. But iron is the good conductor of electricity because of valence electrons in that, and they are movable in nature, so that they can pass electrons from one place to another place very easily. Iron forms the soluble salt. Whenever iron salt is taken, that iron salt, whatever iron salt was taken, ferrous sulfate, let me take ferric sulfate, let me take ferric chloride, let me take ferric chloride when added to water, red color we can observe. So that is because it is water soluble. Any iron salts are said to be water soluble in nature. Iron forms colored compound. Just now we said that iron chloride when added to water we will get a red color solution, and ferrous sulfate if you are added to water, so that we will get a green color solution. That is a colored solution. Iron complexes are colored in nature. What is the reason for color of the complex? Because of odd electrons in its outer shell. Electrons having tendency to move from lower energy level to higher, which is called a DD transition. D orbital to D orbital transition is possible. Iron has the variable oxidation state. Just now we said iron plus 2 is there, iron plus 3 is also there. So that variable oxidation states are possible for iron. Iron acts as a catalyst, right? So iron is a better catalyst. Whenever iron was taken, that iron used in the various kind of polymeric synthesis, various reaction passage reaction movement in the research purpose, so that whenever reactants got treated, the catalyst is very essential to fasten the rate of the reaction, so that in general transition metal complexes are good catalyst only. In specific, iron is also the kind of such a compound where fastening the rate of the reaction is possible. Iron forms a basic oxide. If you go with ferric oxide is basic in nature, because any metal oxide is said to be basic. Non-metal oxide is acidic. Simple to remember. I'm taking that sodium oxide, lithium oxide, magnesium oxide, calcium oxide, rubidium oxide, cesium oxide. At the same time, iron oxide. All are metal oxides only. Any metal oxide must be basic in nature. If you go with carbon dioxide, silica, SiO2, silicon dioxide, all these are non-metal oxides, so that we can say acidic in nature. This is the way nature of the oxide depends upon the either the element is metal or non-metal. Metallic oxides are basic, non-metallic oxides are acidic in nature. This is the way all the properties got justified for iron, right? Move on to question number 3. Question number 3 collected from JEE Advanced 2018 question paper 1 question it is. Again, it is collected from inorganic chemistry. The total number of compounds having at least one bridging oxo group among the molecules given below. These many molecules are provided to you. Among all, how many molecules are having bridging oxygen, not bridging element. Rather, in specific, they are saying that oxygen must bridge two metals or two elements. So bridging oxo group must be present in the molecule. We have to count how many are there. In order to answer this question, everybody should know about the chemical geometry of the given compounds. 1, 2, 3, 4, 5, 6, 7, 8. 8 compounds are provided, among 6 are having that bridged oxo functional group. So let's see. N2O3, dinitrogen trioxide. N2O3, if you observe, if you see, there is a resonating structure. Nitrogen bonding is there in one structure, where another compound is having oxygen bridging among the two nitrogen atoms. So that we can say N2O3 is having bridged oxo. Oxygen is bridging two nitrogens, right? So that put a tick mark here. And move on to another compound, dinitrogen pentoxide, N2O5. Dinitrogen pentoxide, if you observe, nitrogen to oxygen beta bond is there, nitrogen to oxygen double bond is there, nitrogen to oxygen bridged bond is there, so that we can put a tick mark here. So that oxygen is a bridge in between two nitrogens, so that here also you can find correct answer. Move on to another, H5P3O10. H5P3O10 is the compound where you can found repeated such a phosphoric acid units. All the phosphoric acid units are repeated with the ether linkage. That means oxygen is bridging among. So if oxygen is bridging, what is our intention? That should be the answer of our question, right? So H2SO2O3. When H2SO2O3 is taken into the consideration, there is a sulfur-sulfur linkage, sulfur-oxygen, sulfur-oxygen, sulfur-oxygen. But there is no bridged oxygen. So that need not to put the tick mark here, because we are not having bridged oxygen. H2S2O5. H2S2O5, if you consider, there is a direct SS linkage, but not oxygen bridging. Oxygen bridging is missing, so that we can't answer this. If you go with H4P2O5, H4P2O5 is the kind of dimer. So in this dimer, oxygen is a bridge in between the two phosphorus, so that put a tick mark here. So here we have phosphorus oxygen double bond, phosphorus OH bond, phosphorus hydrogen bond. See, here the hydrogen is said to be hydride. Hydrogen is having hydride nature. And oxygen is the bridgehead. And another compound is P4O6. P4O6 where phosphorus are 4 and oxygen are 6. So that here you can find how many bridgehead oxygens? One bridging oxygen, second one, third one, fourth one, fifth one, sixth one. Six bridgehead oxygens are present within the molecule. P4O6 is having 6 bridged oxygens. All are bridged only, no free oxygen. If you go with P4O7, P4O7 if considered, P4O6, P4O7, what difference you can find? Only one oxygen is extra, that is double bond O. So except this double bond O, rest all will be the bridgehead oxygens only, so that we can put the right mark here as well. So these many you can find, let me count 1, 2, 3, 4, 5, 6. 6 answers are correct for compounds having bridged oxo functional groups. For question number 3, 6 bridgehead oxygens are the correct answer. Move on to the fourth question. Galena is partially oxidized by passing air through it at high temperature. After some time, the passing of air is stopped, but the heating is continued in a closed furnace such that contents undergo self-reduction. The weight in kilograms of the lead produced per kg of oxygen consumed is. Atomic weights are provided for oxygen 16, sulfur 32, lead 207. Remember this, which is very essential to solve the problem. Here, let's repeat the last word, last sentence, sorry. The weight of the lead produced per kg of oxygen consumed. So whenever it is oxidizing, how much lead will be produced in kilograms whenever kg of oxygen consumed for the reaction. Galena is the starting material. This will be the ore of lead. Galena is the essential ore of lead from which you can extract the pure form of lead. The expected answer is 6.47 kilograms. Let's see how to solve this. Lead sulfide upon oxidation, lead plus sulfur dioxide will be generated so that pure metal will be extracted. Lead sulfide is called what? Galena. They are saying that how much oxygen consumed? Oxygen is 1 kg. So let me put 10 to the power 3. Then what is the weight of oxygen molecule? Oxygen molecular weight is 32. Number of moles is equal to weight by molecular weight. Weight is given by 1 kg, 10 to the power 3. Molecular weight is 32. So this is for what? Oxygen. Move on to moles of lead formed. How many moles of oxygen consumed? How many moles of oxygen consumed? Those many moles of lead formed, right? So that let me put same. But so number of moles of oxygen is equal to number of moles of lead formed. So that 10 to the power 3 by 32 we can put on. This is for what? Number of moles of lead formed here, right? If you know the moles of lead, obvious to calculate the mass of the lead formed over there. What is the weight? We can easily calculate. What is the formula for weight calculation? Mass is equal to number of moles multiplied with its atomic weight. We are calculating lead amount, so that lead atomic weight to be taken into the consideration. Moles of lead are 10 to the power 3 by 32. Then atomic weight of lead is 207. 10 to the power 3 by 32 multiplied with 207. So that we will get 6,468 grams, because 10 power 3 is the gram terminology. But in order to convert the grams into kilograms, what we have to do? This can be divided with 1000. 6,468.75 can be divided with 1000, so that we will get 6.4 kilograms. 6.47 kilograms. 6.47 is the expected answer we got in a systematic manner. Very simple two-step answer we got. So first of all, we have to find out the moles. Moles can be converted into a weight. So for question number 4, answer will be 6.47 kilograms. Move on to question number 5. Question number 5 collected from organic chemistry. The IUPAC name of the given compound. The compound is provided IUPAC name to be assigned. IUPAC stands for International Union for Pure and Applied Chemistry. And this is the one with the 7 carbon length chain. Let me count. 1, 2, 3, 4, 5, 6, 7. 7 carbon length chain with the aldehyde, ethyl, methyl, double bond, OH functional groups. So expected answer is 2 ethyl, 5 hydroxy, 3 methyl, kept 3 enol. Let's see how can we answer this. Okay, first of all, let me put numbering over there. 1, 2, 3, 4, 5, 6, 7. And identify what functional groups are there and which carbon atom. On second carbon, ethyl is there. Third carbon, methyl is there. Third carbon, double bond is there. Fifth carbon, OH is there. So that uh, in order to give the name, so here ethyl is there, methyl is there, hydroxy is there. There is the competition among all, but we have to go for alphabetical order. Eth come first over meth and hydroxy. So that let me put 2 ethyl. E is the alphabetical order. E comes first. That's why 2 ethyl. Later on fifth carbon hydroxy is there, 5 hydroxy. Then 3. On third carbon double bond is there, 3 methyl is there, and 3 ene is there. So both. On third carbon methyl is there, double bond is there. Let me put 3 methyl, 3 ene, both. And parent chain. Parent chain is 7 carbon length, so that let me say hept. And being it is the kind of aldehyde, always aldehyde in the IUPAC nomenclature given with all. So the T in all, 2 ethyl, 5 hydroxy, 3 methyl hept, 3 enol is the right naming for the given organic compound. Move on to question number 6. Question number 6 is the last question of the session. The aromatic compounds are species with the maximum number of pi electrons in it. We have to go for counting the number of pi electrons, not the number of pairs of pi electrons. Number of pi electrons to be counted. Okay. The options are phenanthrene, naphthalene, cyclopentadienyl anion, cyclohepta, trinyl cation. 4 options are provided. We have to go for which is the correct answer. Phenanthrene. Phenanthrene is a, how many ring systems you can notice? 1, 2, 3. So it is the triannular ring. What we can say? Triannular ring. And this is the kind of angular system. This is all rings are not staying on the same line. If all the rings are staying on the same line, we can say anthracene. But if you are going with the annular type of ring structure, that is called a phenanthrene. There is a kind of isomerism within the molecule based on its linkage. And count the number of bonds first. 1, 2, 3. So we are going to count pi bonds present in that. Whatever double bond you can observe, that double bonds we are counting. 1, 2, 3, 4, 5, 6, 7. 7 pi bonds are there. Obviously, 7 multiplied with 2, 14 pi electrons are available. 14 pi electrons in phenanthrene. Who want to naphthalene? 1, 2, 3, 4, 5. Pi bonds are only 5. How many ring systems are there? 1 ring, second ring. So it is the biannular ring system. And 1, 2, 3, 4, 5. 5 pi bonds can be multiplied with 2. 10 pi electrons are there. 14 pi electrons in phenanthrene, 10 pi electrons in naphthalene. Move on to cyclopentadienyl anion. Cyclopentadienyl anion is having 2 pi electrons, 2 pi electrons. This is the negative charge bond to be treated as a pi bond. So that we can say possible pi electrons are only 2 plus 2, 4 only. And move on to this cyclohepta trinyl cation, which is also called a tropylium cation, more stable aromatic. So this is the tropylium cation where you can notice 1, 2, 3. 3 pi bonds are there multiplied with 2. So the 10 pi electrons are available. So 10 pi electrons, 4 pi electrons, 10 pi electrons, 14 pi electrons. They're asking for largest number. Maximum number of pi electrons where phenanthrene molecule is having. So that for question number 6, option number 1 is the correct answer. By this, we entirely completed the session. Each and every question is very unique in nature, and its own importance it is having, and obviously it is more important towards your coming examinations. If you are preparing seriously, definitely you can achieve whatever goal you are planning for, you are dreaming for, right? Hence, I'm sincerely requesting you to like the channel, comment which part is important towards your preparation, share with us parents, as much as possible and subscribe the channel to achieve more such kind of updates in the near future. Thank you very much for your patient listening. Thank you one and all.